So last time we introduced the concept rolling without slip, right? And there are two cases. If you look at the board here, that's a case one when you only have a wheel on a fixed surface. So the surface is fixed. In that case, we 100% know what is happening at point C, which is a contact point. And at that contact point, we know both acceleration and velocity, right? What is the acceleration? Acceleration on x direction is 0, since the ground is fixed. The acceleration on y direction equals omega square r. That should be on your notes. That's case one. So whenever you see a problem with no slip condition, if that is the case one, you should write out all those given informations. Well, it's not given, but it's hidden behind that no slip condition. And that's our case one. And we did example on case one, that was the example 2A6. And the second case for rolling without slip, it's when you have a wheel that's on a block. That block is sliding on the surface. So the wheel is on top of that block. So that's a case two. Under this case, we know everything about velocity at point C. However, we only know 50% of acceleration at point C. So acceleration at point C, we only know the x direction equals the acceleration of that block B, but we don't really know what is the acceleration on y direction for case two. So in case two, we know velocity on x and y direction. Keep that in mind, the velocity is not 0 because the block B is moving. For acceleration, we only know the acceleration on x direction. That's equal to the acceleration of the block. But we do not know the acceleration on y direction. Okay. Those are the no slip cases we learned last time. Okay. Now, start from last week. I feel like the morning class are getting very quiet. Most of you are sleepy. Okay, how about let's all stand up for a few minutes and want you to think about what we have learned in chapter 2. So chapter 2, we learned rigid bodies. We introduced two equations, and now it's rolling without slip. I want you to talk to your neighbors for 3 minutes. Two things to talk about. What are the things that make sense? And what are the things that doesn't make sense to you? Okay, all right, go ahead. Talk to each other. That's good. No worries.
So when you're looking at omega is positive or negative, use the right hand, correct?
Yes.
So clockwise is negative.
So counterclockwise is positive, clockwise is negative. Yeah, that applies for all rotations.
This isn't mine, but I have like.
Okay, this is yours?
Copy of mine.
Okay, okay. All right. Yeah.
So the whole test was out of 60.
It's what?
The whole test, exam 1, was out of 60.
Yes, 60. And plus 10 points bonus points. Okay. Okay. I think you guys had some good discussions. Now you can take a sit. I just ask around, and I'm really interested to know what is something that doesn't make sense to you guys. Okay. Well, let's start here. Anything you guys want to share? Anything doesn't make sense? Anybody want to share like your discussion, something that doesn't make sense?
So why exactly, like fundamentally, why exactly in point C is velocity 0 and I is like what?
Why exactly?
Is it like 0 at that specific point, like that concept?
Okay. That is something you think that doesn't make sense. How come that's 0, right? Okay. Anybody have the same confusion? Raise your hand if you think, yes, that doesn't make sense. The point C has 0 velocity. No? Okay, 1. All right, good. I will answer that later. I'm trying to answer that. Okay. Any other things you think that doesn't make sense?
I guess I'm just confused on the velocities overall, like point A versus point B versus point O, just like what direction they'll be in.
Okay. Okay. Good question. Anything else? Anything else?
I really sometimes with like on this, I think it's usually the second example on the homework when like you have like point B or point A, like knowing how to orient it versus the center, like what direction. Like it's gonna be like positive, like J, like if it comes above the center, it's like positive J, or if it's negative J.
Okay. All right. Yeah, good questions. I can try my best to answer some of those questions before we talk about example 2A4. Okay. So first question I like to answer is why the contact point has 0 velocity. Okay. So that's for our case 1, right? The contact point has 0 velocity. We're talking about a fixed horizontal surface. So imagine this is a fixed horizontal surface. I have a point right here. Cameron? Okay, I'm answering your question. So at this particular point, at this moment, what's the velocity of that point? I'm just asking if we have that contact point right now on this table, that's a fixed surface. Now my finger is pointing at that point. What's the velocity of that point right now? 0. Okay, that's a fixed surface. Any point on that surface should have 0 velocity, right? Now, if I have a pen that is rolling on this desk, think about that's a wheel. And now I'm right at that point C I was pointing at. Should that change the velocity of that point? No, it shouldn't, right? So all the contact point between my pen or wheel and this fixed surface should always have 0 velocity. Because if you take the pen out, all the points on that desk should have zero velocity.
Oh, because the desk isn't moving.
Yeah. That's if the desk is moving when I have something rolling on the desk. That's our case too. So the contact point have velocity, same velocity as the desk, if the desk is moving. Okay, I hope that cannot answer your question. Other questions from Krista. Okay, repeat your question again.
Like, I'm just confused on how to know what the velocities are at each point and their direction.
Okay, good question. So that's in most of the cases we're dealing with a wheel or disc. Okay. Where's the direction of velocity? That's a good question. For example, we have a disk. The center of this disk is O. And what's the direction of velocity for point O? If this disk is rolling on this horizontal surface. Think about what direction this wheel can roll. Can this wheel roll up and down? No, this is impossible. It can only roll to the right or left, which is on X direction, right? So even we don't know what is the velocity of point O, but at least we know if you want to write velocity of point O as a vector, that vector should look like there's something, let's call that X on I direction, which is on X direction. Well, I don't change another one. Let's use A of VOX, represents the speed on X direction, plus 0J. So we know there's nothing. This wheel cannot move on Y direction at point O. That only applies for point O. Since point O is a special point. Remember the video we watched? There's LED at the center of that spoon, and when they take the picture videos, point O has a straight line. The path of point O is a straight line. That tells you point O can only move on X direction along, which is parallel to that fixed surface. And that's how the velocity vector looks like for point O. Okay, since that's a special point. But if we pick any point inside of this wheel, and things can be different. For example, if this wheel is rolling, let's see, counterclockwise with the angular speed omega. And let's look at point A right there. So it's a random point on the wheel. What's the direction of velocity for point A? To be honest, I don't know. But at least I know if I want to write out what is the velocity vector for A must have a I component and J component. Let's call it VAXI plus VAYJ. Because A is a point that is not a special point. It's just kind of at a random position. But there are a couple of other special points you cannot know the direction. For example, another one is on the top of this wheel, the point above, right above point O, on the edge of that wheel. Let's call this point B. So point B, it's right above the center of the wheel. And at that moment, since the wheel is rotating clockwise, the only possible motion for point B is point B is only moving on I direction, which is parallel to the surface. If we want to draw the directional velocity, point B, that's the directional velocity for VB. We can write out VB as a vector. VB at that moment gonna be only have VBX I plus 0J. So at that moment, it's similar with point O. It only has I component. So what is happening at the next second? Let's see. When B is rolled to that position, a little bit off the top. It's called B prime. After 1 second, if point B is right there, it's called B prime. What's the velocity vector gonna look like for B prime? So once it's moving off from that point, the top point, it starts to have both X, I, and J components. So for B prime, it should have both I and J components. If this point B is keep rolling all the way to this point that is at the same, on the same horizontal level as point O, let's give a different name. Let's call that point C. And point C only has J component for its velocity. So let's write out VC. VC gonna be something 0 on I, VCY on J. I think that probably also answers Ashley's question. Is that your question? No.
Yeah, and then so if you're gonna use, okay, like if you're using O to then figure out B, do you put the arrow from O to B and do the L?
Oh, okay, we can explain that later. You're talking about position vector, is that right? Okay. Let's continue this topic here. At point C, that's where the point C has the same level as point O. We only have Y component of acceleration. What if, how about point, let's call it point D, which is past point C. What's the direction of point D gonna look like? Can you guess? Yeah. So if you use your finger, at this point, the velocity is pointing straight down. Once you pass that point, at point D, the velocity starts to pointing at negative direction on both I and J. So if we can write out what is the velocity vector for D, it's gonna look like VD equals negative something I plus negative something J. You can kind of apply this to any point on the wheel. That's kind of the direction of the velocity on a wheel, on a rolling wheel. Okay. Hopefully that answered your question. No?
Yeah, it does. What would we do with radius? For each point, sorry?
What do you mean, what do we do with radius?
Like, isn't there a way, like, I don't know, B of B equals 2R times omega, whatever,
B equals 2R times omega.
compared to O.
2. Okay. That's a good point. That's a you can, yes, if we want to write out what is the velocity for B, we can apply the equation we learned in this chapter, right? VB equals the velocity of another point. In this case, we can pick that the point, contact point. It's called, and let's call that point, we already use C. Let's call point F. If we want to find out exactly what is VB, VB is on the top. VB equals VF. VF is a contact point velocity plus omega cross product R here R should be RB/F. And here I can answer Ashley's question. That position vector RB/F means it's a vector that's started from point F. It's pointing to point B. So if I draw that vector, it should be a vector starting from point F and pointing to point B. That's a vector RB/F. Okay. And since we learned, this is case 1. So VF is 0. And therefore, we can find out what is VB. So VB can be written as omega K cross product. What is RB/F? That vector pointing from F to B, its distance is 2R. The radius is R. 2R on J direction. So here we have 2R on J direction. What's the cross product of omega K cross 2RJ? That will give you IJK. K cross J will give you negative I. So we're ending up with negative omega 2R. So now we know VB equals negative omega 2R. So that's kind of tell us, I think that back to Krista's question. So at the top of the wheel, actually the velocity along the wheel, it's a kind of a function of ratio between the distance from that point to its contact point. So in this case, this is a wheel, this is point B and F. If we know the angular velocity, point B, here we have 2 times, if we only look at the magnitude of the speed, 2 times omega R. Since here we have 2 R's. Let's rewrite this. Let me write that as omega times 2R. And so that point has 0 velocity. Okay, can you guess? You don't need to do any calculation. What is the point in the middle? What's the velocity at point O gonna be? This point is 0. On the top, we have omega times 2R. At point O here, we have the speed of point O is omega times R. Can you guys see that? We can rewrite this O. Instead of writing that as 0, I can write that as omega times 0r. Everybody's following me? At a contact point, the distance from that contact point to contact point is 0. The velocity of that point is omega times 0r. If you go up to the center of the wheel, the distance from the center of the wheel to the contact point, the distance is r. And that is omega r as a speed. If you go further up, the distance now is 2r, and the speed is omega times 2r. What is the speed at the middle, kind of in between O and B? If we have a point right at the middle right there, what's the speed gonna be for that point? It's gonna be omega times what? Something r. What is that something there? So what is the distance here? That's r plus 1/2 r. Is that right? So that's 3 over 2r. So here we have 3 over 2r. So if we want to draw a profile of velocity on the wheel, the length of the arrow represents the magnitude of the speed. It's going to be something like that. So at the top of the wheel, we have the maximum speed. If you go closer to the contact point, the speed reduces. And at the contact point, we have 0 speed. So this is how the speed profile look like. That's why if you're driving on highway at 70 miles per hour, that's a speed from the center of your wheel. And the top of your wheel is traveling double the speed as the center of your wheel. The contact point of your wheel, the wheels are traveling at 0 speed. Does that make sense? And actually, this is something I'm going to learn in the next section, 2BC. It's called instantaneous center. And in that section, you will kind of understand, okay, that point here is actually the instantaneous center of the wheel. But that's all. That's my answer to you guys' questions. Okay, hopefully that gives you a little bit more confidence on what we are learning here in this section. All right. Our next job is to look at example 2A4. If you have 2A4, I want you to look at your book at example 2A4 and try to write down what is the given and what are you trying to find. Okay, so in this problem, we have a spoon with the smaller radius and the large outer radius. And at the bottom of that spoon, there's a block B. It's in between the spoon and the surface. And on the top of this like inner radius of that spoon, we have another block A. So at both contact point, we have no slip condition. Let's call this point D. This is O. Okay. So we know this block A has both velocity and acceleration. But for block B, it only has a constant velocity moving to the left. And what we want to find is the point O, point P, information about point P. Velocity and acceleration about point P. So just by looking at this diagram here, which case does this problem belongs to? Should be case 2, right? We have something that's moving. It's not on a fixed horizontal surface. So this is a case 2. We have moving blocks. So if this is case 2, what are the givens we know just by looking at that no slip? Write down everything you know about point D and point C, which are the contact points. So at point D, that's a point between the spoon and the block A. What is the velocity vector for point D look like? Yeah, so point A, we know that point, the contact point should share the same velocity as that block A. Where's the direction of block A? Block A is moving to the right, positive I direction with the speed VA. So we can write out what is the velocity vector for VD. VD is just VA on I direction. How about acceleration for AD? What is the acceleration for AD? Is this right?
No, we don't know.
Yes, this is a case 2. So the acceleration at that contact point, we only know 50% of the information, which is we only know what is happening on I direction, but we do not know what is going on J direction. Do not assume that's 0. So here we can use a symbol to represent the unknown here. Let's call that just D, capital D. That's something we're trying to find. This is unknown. Okay, those are the information we know from point D based on case 2. How about at point C? What is VC? What is AC? So at point C, the velocity of C is the same as the blocks B. That's case 2. So the block B has a velocity of VB. It's moving to the negative I direction. So if we want to write out what is the velocity vector for VC, VC going to be negative VB on I direction plus 0. J. if you want to. How about for AC? What is the acceleration for point C? If you come back to read this problem, given wave B has a constant speed. Wow, that's good, which means we have zero velocity. So 0I plus 0J. Is this right? This is not right. Even it tells you wave B has zero velocity, that's only on I direction. That's right, 0I. But for here, we're not sure what is the velocity for J. So do not assume that's 0. Give it a symbol. Let's use capital C for this. This something is unknown we are trying to solve. Okay. Now we have all the information we kind of know from the special contact points, point C and point D. Questions? Negative acceleration. You mean for AC or AD? For AC. Yeah, good question. The reason why this AD has AAI, is that because the block A, go back here, in this problem, block A has both speed and acceleration. The acceleration on I direction is AA. That's why that point D share the same speed, same velocity, same acceleration on I direction. But for block B, in this problem, block B, it's constant, so we can say AB, it's 0 on I direction. That's why we have 0 here for BC on I direction. Okay, any other points we kind of know direction? For a wheel, we always have the center as a special point. The center can only move on horizontal direction. So we can kind of write out what is the velocity and acceleration for point O. VO is going to be, we don't know what is VO, but we know VO only has components on I direction. For AO, same deal. We want to find out what is AO on I direction. But for J, would be all zeros. So this two, it's unknown. Okay. Now we kind of only write down everything we kind of know. We haven't started to solve this problem yet. Now we can start to apply the equation we learned from chapter 2. We have a rigid body. We can use the equation to build the links between 2 points. We have different points we can choose here. You can first look at point O and point D. Build a relationship between them. Apply equation VO equals VD plus omega cross RO/D. Can we do that? And that's the first equation we can write. Another equation we can find, it's between VO and VC. It's both point O, C, O, D are on the same rigid body, so we can apply the velocity equation we learned at the beginning of this chapter for this rigid body. So what do we get from the first equation here? We can plug in everything we know. VD, kind of know something about VD. VD is right there. So plug in what do you know about VD? That's VAI. Plus ROD is just a position vector pointing from D to O. D to O, that will give you, that is D to O, that's negative on J direction, small r, R on J direction. Okay. And we can solve this for, break down the cross product plus R omega I. So this is what we end up from the first equation. You got VAI plus R omega I. Question? Yeah, that's because this position vector ROD, yeah, if you have quite confusion about how to decide the sign of that position vector, one suggestion is to draw that vector. ROD is from D pointing to O. So this is RO slash D. That is pointing to the negative direction of J. That's why there's a negative sign there. Let's look at second equation. We can get, plug in what is VC, negative VBI, minus RO slash C. That's a vector pointing from C to O. Let's look at where's that C to O. From C to O, that's this vector here. R D slash C. Okay, so that vector will give you a big R. So if you do the cross product here, we end up with R omega I, big R omega I. This is VO. Let's call this equation 1, equation 2. Just from equation 1 and 2, we're able to find out what is omega. We have two equations, and the unknown here is omega. Both A, VA, VB are given. Small r, big R are given. So from 1 and 2, we can solve for omega. Omega, if you write that as a vector, can be written as negative VA plus VB divided by R plus R on K direction. That's an important step. So when you're dealing with rigid body problems, it is very nice to find out what is the angular velocity of that rigid body, omega, because omega appears in all the equations. We want to use omega to solve other information. For example, in this problem, the ultimate goal is to find out what is Vp, what is the velocity at point P. So now we know omega. It's pretty easy to do. Vp, apply equation, gonna be V, can pick another point. We can pick point O plus omega cross product R P slash O. Since we know what is omega, we can solve what is Vp. Or leave this Vp for yourself. You can try this. But you can write out the solution for Vp. And after class, you can try this yourself to compare your solution with the correct solution here. So Vp has both I plus j. Okay, that's all for today. All right, next time we come back, we're gonna finish this example and solve acceleration. That's interesting.